Hello and welcome to the closeout video on enhancing and evolving the Plutus Simple Model Test Library project within Catalyst Fund10, now known as CLB Emulator. CLB stands for Cardano Ledger Backend because within the new emulator we're using exactly the same set of rules that a real ledger uses. In this video I'm going to talk about what CLB is, what use cases we are considering while developing it, and how you can use it. You can find more information about CLB in several sources. First of all, I suggest reading an article on testing D-apps on Cardano with CLB emulator. You can find the link below the video on MLab's website. This article talks about different approaches one can use when testing D-apps, and mostly it talks about CRM script project, but also it covers the case of using CLB together with Atlas PAB, as well as accessing CLB from non-Haskell environment. In the part of the CRM script use case, if you prefer video content, check out our closeout video on the CRM script project on MLab's YouTube channel. See the link down below the video. To find more practical information about CLB, especially the questions of using CLB, check out our documentation website. Please find the link down below the video. Finally, we encourage you to check out the CLB repository on GitHub. The CLB emulator comes in two parts. The first is the CLB Haskell library. You can use this library as a standalone library or in a combination with Atlas PAB. The first use case is useful if your project is capable of producing serialized Cardano transactions and you just want a state manager that can submit transactions and get you back the current state of UTXOs. In other cases, when you want to have a full machinery for building transactions, your proper choice would be CLB library plus Atlas PAB. In that case, you can leverage Atlas for writing your off-chain code to build transactions, and later you can express tests using Atlas machinery. These tests can be run against a CLB emulator or a real private network without any modifications. We call this feature unified testing. Let's start with the CLB library. Its main module, called CLB, defines or exports everything one might need to work with the library. First of all, let's take a look at the CLB monet. CLB transformer is a state over a CLB state. Okay, so let's take a look at the state data type and its components. The most important part is that chain state data type, which represents the actual underlying ledger state. In addition to that state, we keep track of all datums. This is inline datums plus datums presented as witnesses within transactions. The rest of that data type represents the log and the configuration of the CLB. The emulated ledger state I mentioned before is a pair of two things, the ledger environment and the ledger state. Both data types come from the Cardano ledger repository. The configuration consists of different things. First of all, the configuration for check limits, then protocol parameters, network identifier, the configuration of slots, and the transition config. The API is very simple. In addition to several low-level things like logging and stuff like that we can skip, I guess, we provide the access to the configuration, the access to the current slot, the access to the current stake pools defined within the ledger, and the access to the UTXO set. Of course, we also provide a method for submitting a transaction, which is a core thing. To run CLB Bonet, you can use run CLB function, and init CLB function provides a way of building the initial CLB state. In addition to methods I already mentioned, there are a couple of useful things in this module. Notice that there are actions to working with slots, with parameters and configuration, and also utilities for working with keys. The thing is that initially, upon initializing, CLB library initiates 10 wallets. These wallets are indexed by integers, and the way it's done is deterministic. So you can just always get the signing key for any wallet by providing its index using this function, int to key pair. The API is mostly based on types from Cardano API repository. You can find a real example of using CLB API in CEM script project in clb.hs under Monod's CEM Cardano SRC to get an idea how it can be integrated within a project. It's not expected that a client of CLB should generate transactions in Cardano API format from scratch. For most cases, the traditional approach would be to use CLB in combination with Atlas PAB to do the job. Let's take a look. In Test Unified folder of Atlas repository, you can find a betting application, which is a simple demonstrating application we use to show how unified testing is working. In on-chain subfolder, you can find an Plutus TX implementation, but an Aiken implementation is also available. In Betref folder, you can find operations module. This module contains the most important part of the application in terms of the off-chain code. Let's take a look. For example, place bet. This action takes some parameters and builds a transaction. It returns a GYTX skeleton data type. The reason we decided to switch from original PSM code for building transactions to Atlas is that this kind of testing implies testing both on-chain implementation and off-chain code. When you use Atlas, you can reuse the very same operations like that in your test suite and in your real application. It means when you run your test suite, you effectively test the very same code you are going to run within your application, which definitely much better than testing a separate code written specifically for a test suite. Furthermore, the idea of unified testing allows you to use not only off-chain code, but also tests themselves when you want to run them against different backends, namely the CLB emulator and a real network. Let's take a look at placebet module here. It defines two functions for building test trees. One is for the emulator and the other is for the test network. They are slightly different, but under the hood they use the same functions: simple text test, first bet test, and so on and so forth. Let's take a look how it's done. For example, first bet test. This is a wrapper around first bet test function that takes lots of parameters to specify a particular test, and the test itself does several things. So first of all, we deploy the script because this example uses a reference script, and then we run something inside check function. So we can reuse the actions, the checks, and everything else we need to express tests like that against different backends. This is the whole point of unified testing, which is very useful because tests against an emulator can be run much quicker than tests against a real network. Let's try to do that. You can see that tests are run almost instantaneously. The speed is fast enough to run property-based tests, as is done with an CM script project. It's much faster in comparison with private test network. The other part of the CLB project is a standalone binary, which is partially compatible with Cardano node, so it can be used as a drop-in replacement. You can find it in the emulator folder within the repository. While the CLB library lacks notions of time, blocks, and the mempool, the standalone emulator introduces them in the most simple form. So it has a separate thread to tick the time. It introduces the very simple function to produce a new block out of the contents of the mempool. So that way the emulator can handle some subset of Ouroboros mini protocols. So now let's take a look how it's done within CTL library, Cardano transaction library, written in pure script. The project is based on Nix, and we can pull in the CLB emulator executable directly using Nix Manager. Since it's compatible with Cardano node and CTL uses Cardano test network component from Cardano node repository to spin up a test network, we can just set up an environment variable that way to switch from a real network to the emulator. Let's try to do that. Let me copy this into the terminal and let's run the test suite. As you can see from the output, the average test takes roughly 1 minute to execute. This is pretty slow. Why is this the case? The answer is that you cannot travel in time anymore like it was possible within the CLB library, where the notion of time was missing. Now you have real slots and you have to wait, though you can set the length of slots to reasonably short value. Anyways, this time is much less than the corresponding time if you run the very same test suite against a test network that consists of real Cardano nodes. And this implementation doesn't consume so much resources as real nodes. This concludes our video report on the CLB project within Fund10 Catalyst. Thank you for watching.